Hello, and thanks for clicking on this Prenurculus production. Today, we're going to be talking about properties of logarithms. Okay, we're going to continue our discussion on logarithms. Today, we're going to be talking about expanding logarithms and using the change of base formula to help us to evaluate a log that a calculator may not be able to evaluate. Okay, so let's start with the change of base formula. We know what logarithmic functions are, what they're about, that they're inverses of exponential functions. The change of base formula is convenient for changing logs into common and natural logs. Remember, common logs are just logs with base 10, and the natural log is ln, or the log with base e. Okay, so it's convenient for changing logs into common and natural logs that can then be evaluated in the calculator. So there are some calculators that can't evaluate a log with a base other than 10 or e. All right. If there's any other base for it, like a 5 or a 7 or a 10 or 11 or an 11 or a 15, okay, it doesn't know what to do. All right. It can't actually evaluate it. So if I ask you to use the change of base formula on log of 5 base 7, well, in any case, to evaluate a log using the change of base formula, if I ask you to evaluate log of b with base c, it can be rewritten as log of b divided by log of c using log with base 10, the common log, or you can also rewrite it as the natural log of b over the natural log of c, using log with base e. Okay, both of them will work. They'll both give you the same answer. Doesn't matter how you do it. So if I ask you to take log of 5 with base 7 and change the base, well, we're just going to follow the formula. Log of 5 with base 7 would be log of 5 over log of 7, both with base 10. If you type this into the calculator, you'll get some decimal answer. Or you could also do the natural log of 5 over the natural log of 7. Both of these will give you the same answer, no matter which way you choose to do it. Okay? And that's how you'd use the change of base formula. It's very simple. All right? And very simple to do, very simple to use and evaluate. Okay? All right, so that's the change of base formula. Now, let's talk about some more properties of logs. So we have properties for exponents, and we know exponents and logs are inverses of each other. We have these two properties of exponents we learned a long time ago. If I have x to the a times x to the b, the bases are the same. I can combine them and add their exponents. And if I have x to the a divided by x to the b, I can combine them and subtract their exponents with the same base. Well, the log properties have similar rules to the exponent properties. If I ask you to take the log of a times b in the argument, I can split the logs apart and write it as the log of a plus the log of b. If I ask you to take the log of a and divide by b, a divided by b in the same argument, then I can split them apart and write the log of a minus the log of b, just the same way that I could with this property here. Finally, there's one more property that we're going to use. If I have the log of a raised to a power b, I can take the b, the exponent, and stick it in front of the log and write b times the log of a. Okay? These are the three properties we're going to use to expand logarithms today. So, the idea behind expanding logs is very simple. You want to write as many logs horizontally as you can, okay, using these properties. So we're going to take, for example, the left-hand side that we have and rewrite it as the right-hand side. All right. So, for example, if I ask you to take log of x squared times y, inside the argument, I have two things that are multiplied. So I could use property number 1, which says log of a times b, and I can split these logs apart and use addition. Log of x squared plus log of y. Okay? Now, this 2, that's the exponent. I want to write as much horizontally as I can. So this 2 as an exponent can be taken and brought down into the front of this log using property number 3. So I can write 2 log of x plus log of y. And that's the answer. I've expanded this and written as much horizontally as I can. If there are things that you can evaluate here, which there will be a little later on, you would have to evaluate them. But for now, there's nothing here to evaluate. You can't actually get a numeric answer for anything. So we just leave it. All right, let's try the one underneath. I have log of xy to the 4th with base 7. So the first thing I can do is, since I have, well, there's 2 ways I can go about doing this. I have parentheses raised to a power. So I could take the 4 belongs to both of these, the x and the y. So if I want, I could immediately take the 4 and put it in front of the log. So I could write 4 log xy base 7. Now, I have log xy base 7. These are multiplied. I can split them apart by addition using property number 1. But the 4 belongs to both the x and the y. So I'm going to have to put some brackets or some parentheses around this because I want to make sure that somebody recognizes that the 4 belongs to both the x and the y as its power. And then I could distribute the 4. I'd have 4 log of x base 7 plus 4 log of y base 7. That's one way to do this problem. The other way to do this problem, which might be easier for you, and you can certainly do it if you'd like, the 4 that's out here as the exponent. Well, the properties of exponents say you can multiply each exponent by 4. So we can go right from the top here, right? Log of x to the 4th times y to the 4th base 7. So now I have 2 things that are multiplied. I can use property 1 to split them apart by addition. So I'd have log of x to the 4th base 7 plus log y to the 4th base 7. And then these 4s would come in front of each log using property number 3. And that's the same answer I just got a moment ago. You can do it that way too. So you can distribute the exponent before you go and start using the other properties, or you can put the exponent in front first of the whole thing and then use the other properties. But you have to remember that this 4 belongs to both the x and the y. That's why you're able to put it in the front at the start. Okay, when we split this apart, they both get multiplied by 4. All right. Okay, let's try a couple more. Let's try this one over here. We'll have the natural log of parentheses e over x minus 3 to the 5th. Okay, so we'll do this. We'll try it in 2 ways again. So I can take this 6. It belongs to everything that's here. Put it in the front. And that would give me 6 natural log e over x minus 3 to the 5th. Now, I have the natural log of an argument that's divided. So that's property number 2. It says that I can split them apart by subtraction. So it's going to be 6 times whatever I write here when I subtract them. Natural log of e minus natural log x minus 3 to the 5th. Okay, now this 5 can be brought in front. I won't distribute the 6 yet. I'm going to do it in a minute. I can take this 5, put it in the front, but remember the 5 only now belongs to the x minus 3 to the x minus 3. It doesn't belong to the e. So the 5 can come in front only in front of that second log or natural log, x minus 3. Okay. Now, I can distribute the 6 if I'd like. Let's do that. We'll distribute that in. 6 ln e minus 30 ln x minus 3. Ln, well, let's come over here first. This is a common mistake. Natural log of x minus 3. I could try to split that apart. Obviously we want to write as many natural logs as we can, but the argument here for this one log is subtraction. They're subtracted, x minus 3. There are no properties that allow you to take one log that is subtracted and split it apart. I have a property for log of an argument that's multiplied. I have a property for log of an argument that's divided. Okay, and I have a property to take an exponent and stick it in front. So there's no exponent. The x and the 3 are not multiplied and they're not divided. So this log is stuck like this. I can't do any more. However, what I can do, hopefully you saw it, is that ln e, the natural log of e, that's 1. So I have to write that. So that gives me 6 minus 30 natural log of x minus 3. I cannot subtract the 6 and the 30 because the 30 also has a natural log x minus 3 next to it. So this is my answer. That's one way to do it. The other way to do it would be what we just did a moment ago on the previous slide, where we take the 6 and we multiply it in to each one of those, and we could write the natural log of e to the 6 over x minus 3 to the 30. Okay, now I have the natural log of two things that are divided. I can split them apart by division, or by subtraction, using property 2. There it is. Okay, I can take this 6, put it in the front of that first log, take the 30, put it in front of the second log. The natural log of e is 1. Oops, I forgot the natural log there. And then I have 6 minus 30, natural log, x minus 3. Same answer I just got a moment ago. Okay, it doesn't matter how you do it. Both of them will work. All right, they both work. Okay, let's come down here now for our next example. We have log of x to the 5th over x squared minus 9. So I have two things that are divided, an argument that's divided. I'm going to use property 2, split them apart by subtracting. So I'm going to have log, remember that's log base 10, you just don't see the base, right? Log x squared minus 9. Okay, I can take this 5, stick it in front of that first log there, minus. All right, so now with this, log of x squared minus 9, some things you can't do. The x squared and the 9, I can't split them up because there's no property that says you have one log that's subtracted. No property for that. I cannot take this 2 and put it in front of the log because the squared only belongs to this x, not the entire expression. If the 2 are out here in front of the whole thing, then I can put the 2 out in front. But I can't, it's not there. However, what I can do, I want to write as many logs as I can horizontally. I could take this expression, this x squared minus 9, and rewrite it so that it's two things that are multiplied. And how would I do that? Well, the same way we do most things in this class. We can factor it. X squared minus 9 will be x minus 3 times x plus 3. Now I have two things in an argument of a log that are multiplied. X minus 3 times x plus 3. These can be split apart by addition. Okay, so I'm going to write, now we got to be a little bit careful here. This is the trickiest part. The problem is out here in the front, there's a minus sign. So I want to subtract everything that I write past the subtraction sign. Okay, now I'm going to take this log here that's on the right and split it into 2. So I'm going to need some brackets here to write log of x minus 3 plus log of x plus 3. Because this minus sign has to be distributed to both of them. And it's going to give me log of 5 base x minus log of x minus 3 minus log of x plus 3. And this is the correct answer. You can't do any more with that. the log of x plus 3. There's no property for a one log with an argument that's added. It's a log with an argument that's multiplied or divided. Okay, this is the right answer. You got to be real careful with this minus sign that's out here. When you split these two apart, you're going to subtract both of them, okay, that are there. And that's it, okay? That's how you expand a log. You try to write as many logs as you can horizontally, and then occasionally you'll get a log that you can actually simplify, like this one here, log of e, or natural log e, came out to be a 1, okay? And you should simplify it. And as always, thanks for clicking.